Okay, so now let's cover the circle math portion of the graph in dark green right here. Alright, so we're going to come out of the switch node, whether or not to use bounding box, which is the final part of the group node, and we are going to feed that into a group node called outside. And if we look into the outside, that is a primitive group. Let's highlight that. That is everything that is outside our circle prims group. And we have our circle prims group right there. And this is the outside. And we'll be making use of this group. Okay, and from this group node, you'll see that there are 4 different outputs from this. So it's not too complex. One of these outputs is going all the way to the bottom, so we'll cover that a little bit later on. But we're just snapping this at the end for the cleanup section. We'll cover that a little bit later on. And then we have our main geometry right here. But first, you'll see that there's 2 outputs from the group node heading into this little orange box called Create Surface Centroid. So that is similar to what we did with the groups, but what we'll be doing is we are going to make a center point for this circle, snap it to the geometry, and then we are going to get the direction for each point on the edge of the circle primitive's square shape, subtract it from the position of the centroid to get a direction vector, and we will pretty much move all of those points that will make our circle to the centroid's location and then push them out according to the radius of your choice. This orange box is just creating a center point that snaps to the geometry, similar to what we did with the group section above a while back, but we delete and isolate by delete non-selecting circle points prim group, so we only have our square. For this, we do not need the attribute ID. We do not need to pass that on because we are just trying to find a centroid point and measure its position. We're going to hit attribute promote, and we are promoting the point position to a detail. The main reason we are promoting it is a quick and easy way to get the average position of each point, and that will pretty much give us a centroid. And if you see right there, down below we put an attribute wrangle, vector position equals detail. In position 1, we put this into input 1 because we do not want the geometry from this, believe it or not. We just want to get the average position, so we do not actually need this geometry. So that's why it goes into the second input, or input number 1, as listed in this detail node, because we want to start fresh with our geometry to create the centroid point. So we feed that into input 2, vector pos equals detail 1, parentheses p, and that'll give us a vector of the location of the average position for all of these points. And we create a new point, add point, parentheses, we're going to create it in input 0, and that's why this is blank, because we want just this point isolated. So we're going to create this from scratch out of nothing. Add point 0 for the first input, and then for the parentheses, when you add point, this is what input you wanted in, and then comma, and this is the position. So we are adding a point to the average position of all of the points in the circle primitives group, and we are left with this single solitary point. But as you'll see, it is not on the surface. It is just, like an average centroid, pretty much. And we need to raycast that back onto the geometry surface, and this will help our circle shape conform to the shape of the mesh. And we are just using minimum distance because it's just a point on a small piece of geometry, so we are safe doing that. This ray node needs geometry to cast on, and that is coming once again from our main group node. So this orange box is taking up 2 outputs from our group node, so it's not as complex as it seems because this is a very short graph, so we are just borrowing from this node twice. Alright, so the ray cast from the orange box gets fed into the second input of this node, assign direction and dist attributes to circle rim points. And this is a point wrangle, which we will cover later, but we will be assigning centroid attribute, a distance attribute, and a direction attribute. All right, and this node is a little bit later down the line, so I'm jumping ahead here, but let's go back up to the graph. From our main group node, that is the first node in the circle math section, we come out and we have a poly extrude node. We are going to extrude the group circle points prim. For the inset, we are putting a very, very, very small amount, because whenever you inset something too much, the geometry starts to overlap. But we don't really need this to be inset or extruded at all. It pretty much just is at a very small value, just so it creates a new edge loop for us to make a circle out of, and then the remainder that it leaves behind will be a transitional edge loop. And so this way it's not a very harsh circle out of a grid structure with lines converging into a circle with all sorts of lengths. It creates a new edge loop to make a circle out of, so there is an easier transition. We'll not need to extrude any distance out of this. We just need this to be above 0 in the inset value, so it creates a new edge loop. Otherwise it will not do that if it's at 0. And we will move this later on with our circle math functions down below. Extrude the circle points prim group, and down below we're going to output these groups right here in the side group. We were going to call that extrude side. The front boundary group, extrude front seam, we'll call that, and we will call the back boundary group extrude back seam. The groups that I just explained, this group right here, that is what we extruded and moved to a circle shape. So that is the extrude front seam group, this rear transitional edge loop that is from our original geometry, that is called extrude back seam. And these primitives that are in between are the side group. After our poly extrude, we are ready to get cracking. We are going to promote the group extrude front seam to a point group, but we will keep the original group for the time being. All right, and if we have a look at our viewer, we have a new point group called extrude front seam, and you'll see those are the border of the circle prim square that we made, and those are the extruded points that are very close to the original geometry. They are not moved yet. We will move them eventually here, and this again is the attribute wrangle node that I mentioned before. So this assigns a centroid v at centroid attribute to each point. All right, so the second input in this, once again, is our raycasted centroid point. We create a vector centroid attribute, which equals the position of that main single centroid point that we raycasted. There, it's grabbing that position and assigning it to the centroid attribute, 1, p, 0, point number 0, because that's the only point in there. We're making a distance attribute by subtracting the position of each point in the extrude front seam group. So this is a point wrangle. We're operating only on the extrude front seam point group as highlighted there at that circle. We're grabbing each point's position and subtracting the centroid's position from it to get a distance and a direction. So you get the distance node, you put in the position of each point, you put in the centroid, and it'll tell you how far each point away is from the centroid. Then we get our direction group, which is a vector, v at direction equals, and we normalize it. We just grab the centroid's position right here, and we subtract the position of each point one by one, and that'll give us a direction telling us which direction the point gets pointed towards as we expand it from a circle. So once we contract each point to the centroid's position, this will tell us what direction to move the point back into a circle. All right, we're coming out of that node. We are going to split out into 2 different directions. Once again, get the shortest distance for a default radius. We're just creating a default radius, so whenever you create your hole, a hole that shows up that is at an appropriate radius is the default. How do we do that? We delete non-selected points, extrude front seam. So we are isolating the extrude front seam group that we just made, and we have only points left. We are promoting the distance attribute to a detail attribute, except this time we're doing the minimum. And this will tell us the distance from the closest point to the center. That's what the minimum is. It's a least distance point, and it'll give us that distance, and we will use that as a base radius. And this way, when we make our circle, it'll make sure the circle does not overlap and spill over into the main geometry. So it'll make sure the circle is totally contained within this square, because if we got the longest distance, it would, again, overlap. All right, and we are feeding this information, the shortest distance, the closest point to the center, which will probably be right here to here. It'll get that distance number. We will plug that into the second endpoint of this attribute wrangle at detail base radius. And this is a detail attribute. We are feeding in our main geometry into the first input, and we are just making a detail attribute called base radius, and it'll equal the distance coming from the second input. So detail 1, distance And so our base radius will equal the shortest distance from the centroid point to the closest point. And then finally, this is an exposed parameter, set radius VIA input 1. And you'll see the radius input parameter right here. And once again, if we move up to the root of our HDA, this is what this does, base radius multiplier. You can see that working right there. And our geometry looks a little bit funky because the display flag is much earlier in the HDA, but we'll leave that at 1 and dig back inside. And pretty much what this does, it is creating a Avg distance. We're just making a new variable in a point wrangle for this called Avg distance, and it's equaling the base radius that we just created in the node below. And we'll be multiplying that by this input right here. And this is by default set at 1. And you can increase this to be more or less. So the radius will, by default, again, be the shortest distance between a centroid and the closest point, and then you just multiply it. And so that determines our radius. Right here, float rad equals channel float, quotations rad times Avg distance. And if you're not familiar with this, this is how you create a parameter below. If you're new to Houdini, you just type in ch, and F for float. If you want to do an integer, you just put an I. If you want to put in a string, you put S. Parentheses, rad, which is the name of the parameter you're making. So again, if you're new to Houdini, you would say float example equals channel int example. Sorry to be patronizing if you know this already, but just in case there's any new users out there, you hit this button right here to create your example parameter that I just typed in. All right, so if you're new to Houdini, that's how you do that. And so what this does is it resets the position of each point in the extrude front seam group. And so it equals the centroid's position minus the direction input. So this is the direction input that we created up here. And this tells what direction to move each point in, so it retains a circle shape that conforms to the geometry. And we multiply this direction times the radius distance. So all the points temporarily converge to the centroid. We subtract the direction input to tell it what direction to move it into, and then we multiply it by the radius. The points, again, go in towards the centroid and then back out again by a uniform distance, which, again, if you're pushing everything out by uniform distance, all the points, that'll create a circle. All right, but we're not done yet, but that at least concludes the circle math portion of the graph right here. Next, we will move on to this very short section, and this is just getting the patch of the circle, whether you want a patch or not, and this will help smooth out the circle shape so it conforms better to the geometry. You can see the difference right there. That's where the final magic actually happens. So we'll cover the patch or no patch section of the HDA next. Okay, the next two sections are fairly easy. All right, so we split off from the circle math part of the graph from the final node, the set radius VI input, and we get two delete nodes, the circle points prim, delete selected to isolate the geometry with the circle hole, and then we delete non-selected on the patch side to get just the circle points prim by itself, and we will make a patch out of that. All right, from that isolation node, we create a smooth, and this is applied to the extrude side. Remember, we made that group up above with the extrude node, and this is where it comes into handy. We are going to smooth only this portion, leaving the geometry, rest of the geometry intact, and it's bound at unshared edges. So what that means is it will not affect the shape of the circle, only this edge loop right here, and that is exposed at the top of the graph right here, border loop smooth, and you can see it take effect as I move the slider. So it's only going to affect that edge loop, and you can change the filter quality right here. And then finally, we no longer need the extrude front seam points group. We already did our circle math, so we will delete that to clean up our graph a bit. And on the patch side, we are again isolating the circle points prim group, delete non-selected. We are smoothing that. And once again, we have unshared edges checked, so the outside of the graph will be unaffected. You can see the before and after that does. does not affect the outside edges. That's what unshared edges mean. You might say to yourself, how is it constrained to unshared edges? I see the profile, this corner disappear. That actually is not an unshared edge. That is one of the interior points poking out. So we need to fix that before we finish up this HDA, and that's what the smooth group does. And that is expose up above right here in the use patch option. And you get to smooth it out and you see the difference. And then, yeah, so that is an interior point, not an edge point. So that's why it gets smoothed out and why we need that. And I've exposed these parameters just in case anyone wants to play with it, but I doubt it's really important for the actual patch. All right, and you'll see an indent right there with the smoothing section. You'll see it goes inward. We need to fix that. That'll come later on. Dig back inside. All right, we're going to clean up our graph with a group rename. The circle points prim will become the patch group. And that way, once you apply to your HDA, you can just simply grab this as a patch and delete it or extrude it and do what you want with it. We're going to close the section with a switch, whether or not to use the patch, and expose that, which again is located right here. Use patch, that's what this toggle is. All right, and if you do not want to use the patch, this option right here, that feeds into input number 1. And input number 2 is using the patch, so we will merge these together. We will do some more cleaning, group delete, extrude front seam, the edge group, we will be deleting that, we don't need it. And mainly because we are faceting this. And what this does is it just connects the patch to the main geometry again. Otherwise, it's going to be two separate pieces that lay on top of one another. And we are going to promote the point group from this to an edge group, only include elements in the original group. No matter what section of the graph you select, whether it's with a patch or without a patch, the extrude front seam points group will be deleted and we'll just keep the extrude front seam edge group. All right here we are deleting the edge group, extrude front seam, and converting the point group to the edge group. That may sound confusing or redundant. And the main reason is once you facet this, we need to facet this to stitch the patch back onto the geometry. Once you facet that, the edge group gets distorted by the facet and no longer exists. So that's why we are deleting it, because it'll get corrupted once we facet it. But the points will still remain. So that's why we are promoting the points to the edge group. That may be a little bit confusing, but it'll make sense if once you play around with this. Because of the facet node, we need to turn the points into an edge group as opposed to just deleting the points group like we did in the no patch version right here. And this all feeds into from our switch down to the final section of a graph in the home stretch now. And right now we are just going to clean up our geometry. Like I said before, we have some indents right here we need to take care of. So to clean everything up, we just snap everything to the original mesh with a minimum distance. And in the second input, like I mentioned before, that is being raycasted from the group 4 node, which is the outside group we created in the circle math portion. All right, so we now have our original shape with our circle conforming to it. Down below, we have a group called circle edge ring. And the main purpose of that is so you can easily divide that and edge loop that up together if you wanted to make further divisions or surgery or modeling down the road. My main goal with that was to put an edge divide node beneath it so we can procedurally create edge loops. However, I made a note right here. The edge divide node that I tried to do that with, you'll see how these edge loops magically appeared. And in theory, we should be able to procedurally make edge loops at will, so we can have further control if we tried to soft transform this. However, there is a bug in Houdini, and you'll notice this group is set to the circle edge ring group, which I just made. So it was only supposed to be dividing those edges and procedurally create edge loops for you, but there is a bug currently in Houdini with the edge divide node. If you zoom around, you'll see that the edge loops are not working or not connecting properly. And so it does not matter what option I select, it's always messed up. And I actually emailed Side Effects about that, and it is in fact a bug that they are working on. So in the future, once I get confirmation that they fixed that, we could probably add that back in. But in the meantime, I'm leaving it out with just a note that is a possibility you can do later on. Whenever they fix it, you could just put the HDA on your model, and after you apply the node, you could probably put an edge divide node, and you easily have access to that group circled edge ring once you pull down a drop down menu. And you could do it like that in the meantime whenever they get around to fixing it, but you can always, again, add it back in later. All right, so after that edge ring group that I just created for easy use by the end user, we apply another group node, the extrude side group node, which is the primitives that make up the border between the edge loop and the actual circle. In case you wanted to do anything with those, we make a group for that. So that is called circle border prims, and that's just the primitives that border the circle shape. And so we are renaming that because the extrude side group is often the default name of the poly extrude node. So we do not want any contamination with if you have any other poly extrudes in your model, that you'll most likely have a group called extrude side, and if you stack this HDA with a poly extrude node, you're going to get some corruption of the group, so we need to rename this. We are renaming that to circle border prims. And yes, there is a group rename node within Houdini. I suggest not using that, because if you look at the original group node, it has an option for conflicts. If a group already has the same name, it can just replace the existing group, whereas the group rename node does not have that option. So what will happen is if you stack multiple versions of this Topo bool HDA one after the other, if you needed to make a second and third circle, what will happen is the first the first instance of this HDA will have a group called circle border prims, and then when you add another, the group rename node will say there is already a group named circle border prims and give you an error message, and there'll be group corruptions, and you'll just have to manually go in and rename the node in between. So so the group rename node, to make a long story short, doesn't know how to handle conflicts, whereas making a new group and just renaming it and putting in the old group as the base group and just giving it a new name here, this knows how to handle conflicts better. You just hit replace existing or union with existing. Anyway, moving on. After that, we are going to rename with a group node the extrude back seam to a more appropriate rear edge group name. All right, so it's more descriptive. You do not want to keep these group names also because, again, if you are using multiple versions of this HDA, the group names will interfere with the math we use in a circle geometry, because we are applying a lot of vex code to certain group names. So you do not want prior versions of this HDA, if you stack these on top of one another, to contaminate the circle math. So the group names need to be unique. So that's another reason why we are renaming everything. I need to be very careful not to use a group rename node. Next up is the front edge. We do the same thing. Get a group node, replace existing front edge, extrude front seam. So if we go into here, you see the front seam group, and it's the same as the extrude front seam. Extrude back seam is now the same as the rear edge. And then we are going to clean everything up by deleting the groups we do not need anymore. So extrude back seam gets deleted, so there's no duplicate groups. Extrude front seam gets deleted, extrude side gets deleted, and we renamed all of these, so we still have groups for them. Outside is no longer needed. Circle points prim and circle points are no longer needed. I close off by getting the extrude front edge group, which is an edge group right there. I promoted that to a point group and renamed it bool point, so you have both edge and point versions of this group handy. And the main reason I did that is the soft transform node requires you to input a point group. It does not do edges. And this way you can further model the shape of your hole with a very nice soft fall off right away just by grabbing the group bool points. So I'll show you what that does. We set our flag, display flag right there, and we head on back up to the graph. We middle mouse click and we see all of the provided groups to the end user. We have the point group bool points. We have two primitive groups called circle border prims and patch. And we have three edge groups, circle edge ring, front edge, and rear edge. Just go over that once again. In the drop down menu, we have our point selected. There's our point group bool points. Hit the edge group selection. There's our circle edge ring. There's our front edge and rear edge group that we just renamed. Go into our primitives group. We have our patch group, and we have our circle bordered prims group. So you can just use these group names for easy modeling. And let me again show you the soft transform node that I just created the bool points group for. Right, so you get your soft transform node and you just put in the bool points node, and you can just now mess with the handle. All right, and our radius is too big, so that's why the whole arm came up, but you can just decrease this radius. And now you have a beautiful fall off you can do with this and shape your hole no matter what you like. Rotate it a bit. And this just makes it quick and easily modeling with circle booleans, and you retain quad topology there. Let me see, let's change this to edge mode, get a little smoother fall off. And quadratic, more easily see this in wireframe mode. And for a quick example of some of the goofy stuff you can do, I put a subdivide node before the soft transform, and so that'll only affect the bool points and have unaffected points in between because it's subdivided. And now you have a quick and easy way to make little ripples or wrinkles right there. So that's one idea of some fun you can have right there. Make a little seashell. Who knows? All right, and that concludes the overview / tutorial of the Circle Topo Bool HDA. Once again, you can find that on Gumroad and follow along and download that, or you can just make this from scratch watching this tutorial. Okay, everyone, thanks for watching. Once again, please visit gumroad.com/cinema for the HDA file for this. I also have a few other products on Gumroad. Houdini, the automatic hair card making kit for Houdini, as well as a course on rigging a game-friendly character for Unreal Engine using Houdini, as well as a few other products such as the pixel art substance designer filter that you can instantly make pixel art sprites out of for your 2D game or perhaps 3D game with 2D sprites. Also, I am on ArtStation at artstation.com/cinema, as well as obviously YouTube at youtube.com/cinema, and please subscribe. I am almost at 1,000 subscribers. I would like to push that to over 1,000, so I'm almost there. I'm on the doorstep. Thanks for watching. See you later.